Sweet. All right. All right, guys, so we have just a couple of sections in Chapter 4 to finish that out. And then I wanted to do a little preview of Chapter 5 and 6. If you see on your course outline, the homework sheet, there's like a mixture 5-1, 6-1, 5-2, 6. It's because Chapter 5 and Chapter 6 are almost the same thing. It's just looking at the same thing from two different perspectives. And it makes more sense to talk about them at the same time. So you'll see when we get there. So 4-5. And I think I said this at one point, that we're going to learn a lot of different functions, a lot of new functions, and the minute we learn them, we want to learn their opposites so that we're able to solve equations with them in it. But the first type of equation I want to show you is something we can do a little more directly, but it doesn't always work. So for example, these are equations with exponentials and logarithms. So for example, if I had 3 to the x plus 1 equals 27, that actually ends up being an incredibly easy problem. And why is that going to be a really easy problem, do you think?
We know the answer.
Let's get ahead of it. Because 3 is a base that could make 27, right? So I'm going to rewrite 27 as 3 to a power. So 3 to the x plus 1 is supposed to be 3 to the third. X plus 1 has to be 3. So if you can make the bases the same, then you can just equate the exponents, because that must be true to make this equality true. So now, to solve this, this is big. Okay.
Yeah.
Cool. So that's really nice, when you can make the bases the same. What about, I claim that you can do the same kind of thing here on this problem. Well, I like it. It's disgusting.
Oh, yeah.
Careful now.
Obviously.
Yeah. What's the like base here? 2, right? Not 4. I can't raise 4 to a power and get 8. But I can raise 2 to a power. So rewrite 16. It's got the 4x minus 5. You can't do anything about that.
2 to the 4.
But 16 is also 2 to the 4th. And 8 is 2 to the 3rd. What do you do here? What's the rule here? Multiply. I love it. So you get 16x minus 20. You get 9x plus 3. So then what must be true? Sorry? You guys with me?
Equal each other. You just get rid of the 2.
16x minus 20. 9x plus 3. So this is the thing I keep trying to tell all my classes, really. In mathematics, there are processes. The processes do not care what's there. So when I have something with a power raised to a power, I multiply. I don't care what's there. I don't care. Math doesn't give a shit what's there. It's just a general rule for anything raised to a power, I multiply the powers. Here, if 2 to this is 2 to that, this and that have to be equal to make that true. And now I just solve this. You get 7x equals 23. Is that cool?
Yes.
Unfortunately, they're not all going to be this easy, because the minute I could have just made this 3 to the x plus 1 equals 28, and that would just screw this whole thing up. All right? It's too bad. So what do I do with a problem like that? Say like 4 to the x equals 19. Now somebody give me a guess as to what that would be, what the answer would be. Don't tell me how to do it. Give me a guess as to what the answer is.
2 point
2 point something. 2.2, 2 point something. is not very far from 4 squared is 16. 19 is not that far from 16, so it's something barely above 2. So now bring back in the earlier suggestion. Now, I can't rewrite the 19. I'm sure it's 4 to a power. I'm sure it is. But I ain't no way I'm going to figure that damn thing out.
Log both sides.
Yeah, so if I take, in fact, normally I just do that, go ahead and do the ln, because it's got one less letter. Is that right? I'm really not joking. You'll see when you get to calc, you always use ln. You could use log, but it's one more freaking letter to write.
You can scribble ln.
No. ln is base,
E.
and log is base 10.
Was there an example in some cases?
Totally.
It's not the ratio.
Exactly. So remember the change of base formula? Did it matter if I used ln or log? Didn't matter. That actually is the same exact reason why I can do this. I'll do this problem a different way, and actually you can do it either way you want to. But this is the way I really want to show you first, because this is the one that leads into other applications. But then I'll show you how to do this specific problem a different way. But I'd much rather you do this just to get used to taking natural logs of two sides. What happens here?
You take the x and 4.
The whole reason we use this function is because it's the only function that has a property where a power can come down. Every log is the inverse of some exponential function. I'm not using log base 4, but the logs don't care. They all have the same property. That power comes down. Our variable's stuck up there, so I want to take the damn thing down, right? And then what's really the last step here?
Solve.
Yeah, divide by.
ln.
You can't, don't do this. Right? Okay, good. That's the appropriate response to that. This is one thing, this is one thing. Just like you can't divide the square root symbol away. I don't like square roots. Divide by ln 4. So x is this. This is called the exact solution. To get an approximate solution, I would put it in the calculator. It's called approximate because we don't want to write a decimal forever, so we stop somewhere. So what would the approximate answer be to this? Can somebody put that in? 2.124? Blah, 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 blah. Is that cool? Yes, ma'am. But do what now? Yes, cool. That's the second way to do this. I like it. So the second way to do this exact problem, the same problem, or to the x, Jeff. That's a good one. A part 2, sorry. So another way to write this is, how do you rewrite this problem using a logarithm? How do you rewrite this from exponential form to logarithmic form? It would be log base 4 of, of the output is the power. So that's good for the exact solution. But that's no good for trying to find the approximate solution because you don't have a log base 4 on your calculator. So you can just use change of base, can't you? What would change of base say? Yeah. Or you could use log if you want to, that's fine. Which is the same damn thing we just got over here, right? But there are more places where you take logs of two sides, and I want you to get used to how that looks and get used to not making silly mistakes when you do that. Like, I'll get people that will subtract 19 somehow or something. You know, I can't sneak into the natural log and take stuff out of it. You with me? That way, though, works for this specific problem, so if you do it that way, I can't complain. Okay? And just to make really sure you understand, when you do this, you are actually taking log base 4 of both sides. What's log base 4 of 4 to the x? These cancel. So you get x equals log base 4 19. That's exactly what that is, right? So you are just taking a log base 4 of both sides. Yes, ma'am?
I have a question for you. So can we use log instead of ln here?
Definitely.
Oh,
It has to come out to the same answer.
same answer.
Because like Shalane was saying earlier, there's a property about these, the The ratio of logs will actually come out to be the same. No matter what log you put here. Log base 7, log base pi, log base square root of 2. This ratio will be the same. Okay. So I'm not going to make this worse. Well, yes, there's always a way. I like it. This is where the algebra skills kind of sometimes leave us. So we've got to be careful. This is not one where I could really rewrite it using a logarithmic form. Are you with me on that? I can't really do it that way. So I have to attack it. And that's what I was saying. This is one quick example of doing a log on both sides works in more situations than trying to rewrite it does. So what would I do first? Pretty much just gave it away.
Take a log of both sides.
Take a log of both sides. So I'm going to do my ln. I'm going to go ahead and take this down. Is that cool? Because that's the whole reason we're doing it. Is that cool? So when I take ln of both sides, those powers can come down. That's a property of logarithms. So I'll just let you guys absorb. The most common mistake I see is people leave that off, and then they think the 2x is off by itself. But that comes down in front of this. It's got a whole thing is multiplying by this then. The 2x can't suddenly escape somehow and go somewhere else. Now, it's solving it from here where people get confused. And it's sort of related to finding an inverse function for a ratio of two linear expressions. Let me say that in English. If I had to find the inverse function for this, there's that weird step in the middle where you've got two of the same variable. And a lot of you guys got to a point like you got somewhere here. And of course this doesn't make any sense because then y is not really solved.
Yeah.
Right? Oh. So whenever your variable's in more than one place, you just get everything with that variable on one side and then take it out. Then there's really just one variable. No big deal. So in order to get to that point, of course, what do I have to do first with this? Distribute.
Yeah, distribute.
So that goes in. So this is really not a good place to put this in the calculator and get a decimal. Don't do that till the very end. Leave it as ln 38. So you get 2x ln 38 minus ln 38 equals x ln 11 plus 3 ln 11. And now you just get all your x stuff together and your non-x stuff together. So what's got to come here?
Minus x.
Yeah, that's got to come over there. And at the same time, I can add that thing out of the way. You ain't got no x's. Get down here. Yeah, so you got 2x minus, right over there. Equals, those are gone, those are gone. You with me? Just move all your true number stuff on one side and all your variable stuff on one side. Because now what can you do on this side? What can you do here? This sucks because x is in two places, but it really isn't. It's in one place. Right? Yes, ma'am. Oh, let's see. What did I do? So we're cool here. Take the ln, the powers come down, and then I just did what it said. Distribute. What do you do when you're solving equations? What's like the first thing you do?
Distribute.
Distribute. Because then you're able to move stuff around, get all your x's together, get all your numbers together. So to be completely honest, this is the same thing you've been doing since Math 90 or its equivalent, right? We're getting our x's together. We're getting our numbers together. Or however your teacher said it, but it must have been something like that. What's the last step here? Yeah, you divide by the stuff you don't want. This is x times stuff. We divide by stuff, so we get x by itself. This is where you need what's called math stamina to get through a problem. I can hear a lot of you guys having some trouble with that math stamina right now. Over this business here. Now, if you want to plug this in the calculator, here's what really sucks about this, especially those of you with the, I don't know how the new calculators do with LNs, but I know the old ones opens a parenthesis, so you better close it, damn thing. Opens, close it, opens, close it, opens, close it. And then you better tell it what the top is, and you better tell it what the bottom is. So that's how you should put it in your calculator if you want to do it all. Yes, ma'am?
There's no special thing if you want it, that 2ln38, you just type it like that, right? 2ln.
The old TI-84s open a parenthesis for you.
Yeah.
Do all of yours? If you type in,
Yeah,
everybody do LN. Does it have this?
Yeah.
Everybody not? Okay, so I'm not jealous of any of you. We're all in the same boat when it comes to that.
Are you waiting for them to make it so you don't have to have a parenthesis?
That would be awesome. That's like waiting for Microsoft Word to let go of all its shit it does. I think you mean this. No, I don't. Anybody else understand what I'm saying? Thank you. I meant to capital. No, I didn't. Yes, you did. No. Okay. How are we doing so far with that? So this is the exact answer. Anybody have an approximate answer they want to? 2.22?
Oh, yes.
How can you check that answer? Plug it in. Do 11 to the 2.22 plus 3. And do 38 to the 2 times 2.22 minus 1. And see if they're about the same. It won't be exactly because that's probably an approximation. Obviously an approximation. But it should be pretty damn close. Right? You check it the same way you always check equations. Plug it in. Okay, cool.
So there's no way to simplify that further by hand for the exact answer?
There's things you could do. I mean, obviously, let me talk about this real quick. You certainly on the top, you could do natural log of 11 cubed, for example, and then you can do ln of 11 cubed. I mean, but is that really helping? I'd have to say no. You kind of with me? You certainly could do that. Apply properties of logarithms to simplify it. I'm telling you right now, don't do that.
It's just too much work.
Just extra work, not make it any better. Yeah. Okay. All right. So. Here's a slightly different type of exponential equation. Sure.
It almost looks quadratic.
Well, it is quadratic.
The key thing here is this is quadratic. This is quadratic in e to the x, right? This is quadratic in form. Oh yeah. What does that really mean? I don't know. As long as the middle dude's power is half the first dude's power, you can try to factor it, or you can use quadratic formula. Whoa. If you use quadratic formula, you have to say e to the x equals negative b plus or minus blah, blah, blah. Because that's really fundamentally what you're solving for here, right? But I can factor this. Now here, let me show you. Guys, let me show you a little trick that works with this and some other things. It's called substitution method. Exactly. It's all about u. If you say u is the middle dude, then what's e to the 2x? What did it do to u to make it this? Yes, u squared. Isn't e to the x squared? Isn't that going to be 2x? Right up there. So how can you rewrite this then? E to the 2x is u squared. E to the x is u. And that looks a lot better.
And then you just change it back.
At the end, it's a really good point. If you stop with u equals whatever, that doesn't make any sense. I'd be like, what the hell's that shit? I'm asking about x. I didn't ask you about u. Right? I don't care about you. So this is just the middleman. This is just to make the problem look better. I haven't fundamentally changed the problem at all. It's still something I don't know squared minus that same thing minus 6. So something I don't know squared minus that same. I haven't fundamentally changed the problem at all. I've just made it look better. That looks a lot better to me than that. How do you factor this? That's right. So u is, of course, whenever you substitution method, my grammar goes to hell. You know, it sounds like u is
plus
3.
3.
Or u is
Not
2. So what's u exactly? You better bring back in
e to the x.
this.
Cannot work.
Can't happen. Good. Because remember, e to the x, it's always in the upper quadrants as an asymptote at 0. How in the world could it go negative then? So that gives me no answers. But this, how do I solve this? Just take.
Back up there and
See, now ln works here beautifully because it'll just kill that.
Yay.
How are we doing so far? Are we? Okay, so you'll see a few like this. When you say to yourself, that looks kind of quadratic, then it probably is. Yes? You can't raise anything to a power and make it negative unless it starts off negative. And e is not negative. Right? And e to the x looks like that. And here's negative 2. So it's never going to have that as an output. Yeah. And as I say that, it's never going to do that as far as real numbers. And that's all we want on this problem is real numbers. Yeah. Oh yeah. This function was on my junior math competency exam. It's still in my head after all these years. And that was just part A of like part A through F of analyzing this damn thing. This thing is way freakier than any of you guys apparently could imagine. Most of you guys got that it can't be 0. I appreciate that. But there's other things it cannot be. Can't be any negative number that would end up with the square root or some even root. So a very basic example would be x equal to negative 1/2. Wouldn't that be negative 1/2 to the negative 1/2? Can you take a square root of a negative number? When I talk about domain, I mean real number, so that's not going to work. What's the matter? So when I have a function and I ask about domain, that's understood to mean real numbers.
Got some of it right.
We normally talk about graphing that thing on a real coordinate axis, right? So I cannot have a negative number to a even root. Can't take an even root of a negative number because that would be complex. It's not going to be part of my real domain. You guys semi with me? So 0 to the 0 power is obviously bad. But so is anything like this. That's fine. Nothing wrong with negative 2 to the negative 2. I didn't say anything wrong with that. I have a problem with even roots of negative numbers. Cool. Beautiful. Because can you take an even root of a negative number and stay real? No.
Negative 1 and then negative
Yeah.
2. No.
It can't be all reals. That's for damn sure.
So it can't be negative, even rational.
It can't be negative numbers that would end up as even roots. So it can't be like negative 1 over an even number. You with me? And it can't even be more than that. It can't be negative 3 over an even number. Or negative 2 over an even, that would reduce, but that's already kind of captured. Negative 5 over an even number, and so forth. So if I would have seen any of that kind of thinking, I would have given some points. And as bonus, I could be as evil as I want to be. On bonus.
Cross
So it
log.
can't be negative odd.
When you say junior competency exam,
What is that?
junior.
So when you're a math major, and I was going to,
Yale?
I was going to Virginia Wesleyan College, a small 4-year liberal arts college.
Oh, yes.
And when you're a junior and you're in your math major, you have to take that exam to make sure that you're on track to get the degree. So if you fail that, you have to retake it. If you don't pass it, they're not going to give you a degree.
So we shouldn't feel bad. That's what you're saying. We shouldn't feel bad.
So
No,
did
you
get
really
it
shouldn't
right?
feel bad. Because I don't think... I got some of it, but I didn't get the whole story. Because there's actually even more in this. Yeah.
Yeah, you're not giving us the answer.
If I would have seen this kind of thinking, that would have been great. Really, the problem is how do I write the answer effectively is really what the problem comes down to. But if I would have seen any of this kind of thinking, I would have been like, oh, cool. And I would have given some points.
How do you graphically enough to be a -2, but it can't be -1?
I love it. This thing is so funky if you try to graph it. If you try to put it in your graph calculator, I don't know if any of you guys have tried that yet. That's the first thing I would try. We weren't allowed them in the test itself, but afterwards I was like, look, damn, put this damn thing in here.
It's just literally
Exactly. And there's nothing on the other side. Because the graph calculator cannot handle something that exists and then immediately doesn't, and then it immediately exists again, and then immediately doesn't. Graphic calculator just says, screw that whole side. And I don't blame it. That's a place where the graphic calculator lets you down. It's not true what it's saying.
And it's you down on this one too.
Ah,
Yeah, you can tell.
sounds like a TLC show coming. Graphic calculators let me down. Okay. So that's an aside. So what about, we've done exponential equations. Now at the beginning I promised you that this section had some logarithmic equations also. So I don't want to let you down. I will start off easy.
Yeah.
This should be remarkably easy.
Okay.
Okay. Walk on the beach. Oh, cool. More advanced. So what's the answer here? Okay, x equals 7 to the negative 1, so x equals 1/7. Cool. Is that all right? So, very basic equation. I just have to rewrite it to solve it. Rewrite it from logarithmic form into exponential form, and I'm done. That's cool. So what about this dude here? Let's do this. Bless you. Good. I can do one step and I got something that sort of mimics this format. It's one step away from that because I know what the difference of two logs is.
Combine it.
Do I?
What's x minus 1 over?
Yeah, it's log of the quotient. So it would be,
X minus 1 over x plus 1.
and now it's the same idea. Log base 2 of stuff is 3, so stuff equals
3 squared.
2,
Or 2 to
Cubed.
the third. 2 to 8.
so 8. You guys see that? So if it is one log, that kicks ass. If it's not, okay, make it one log. Right? Then you do the same thing, it kicks ass again. So now I got to continue. Got it. Now how do you solve that?
We get rid of the denominator.
Okay, so you multiply by x plus 1. And now that looks nice. Yeah, so 7x equals negative 9. So x equals -9/7. Now the one thing you have to be careful about, remember when you did square root equations? In fact, it was on that test 1 that some of you recently corrected. What did you have to be careful about at the end? To check your answer to make sure it actually works, for one thing, right? So, logarithm is the same idea. I can't take a log of what? What can I not have in here?
Negative.
A negative number, or even 0. So if my answer was x equals 1, I'd have to throw it out.
Well, it can't equal 1.
Yeah, exactly. You can see it in what the rewrite also. But -9/7, is that okay? Why not? Because it makes this and that negative. So what's the answer then?
Not defined. No solution.
What's up?
But then you would get a -7x equals 9.
Okay, cool. You guys understand? So the basic thing to go in that, a note to make and maybe put a box around it and stars, is always check answers with logarithmic equations. Much like we have to check radical equation answers. Yeah.
Not the answer is no solution because it's a negative.
Because that, not because this is a negative, but because that makes these inputs negative, and logs can't handle negative inputs. Yes?
Can you put these equations in that basic form, like m and all that stuff, and where all of the numbers are variables, and show where they go as log and exponential? You know what I'm talking about?
Sort of. Like we did when we did the properties.
Yeah, the properties. Can you put down the properties? How they look like?
Okay. So there's the one we used just in reverse. Right there, right?
Sure.
Because we had this and we made it into that. Or just the other one now. Okay. I erased it though. I'm not going to go through all of them because they're in there in the property section.
But they're in book, right?
Yeah. Oh yeah.
The properties.
Oh yes.
Okay.
And they should hopefully be in your notes also.
So we just
Yeah.
look at
Okay. Let's see. Make sure it's nothing I forgot. No. Cool. So one last section in chapter 4. And that's section 4.6. Two L's?
No.
One L? Just like yodel.
It'll be,
We got growth and decay. For one thing, right? Population growth. Put so much bacteria into a petri dish and you come back a few hours later and it's right? That kind of thing. Decay, like you have some uranium laying around and you come back a few thousand years later and you see how much is decayed by, how much radioactivity is lost.
Uranium for like a trillion years.
I know. So that's what this is really talking about. And I think when I first introduced the idea of E, at that moment I said that it's the most useful thing for modeling population growth and radioactive decay, for example. Okay. So the format for this is I'm on page 342. This is section 4.6. So I don't want to spend a ton of time in this section because it sort of depends on which direction you go from here. If you guys are science majors, you're obviously going to see this in a few different situations. If you're business majors, you'll actually see this in other, obviously, situations you don't talk too much about uranium decaying when you're a business major. So we'll probably use it in some different way. But what's going on here is n is the number. This function here is the number at time t. So it could represent the number of rabbits after you've thrown some rabbits in a room. It could represent the number of radioactive particles left after a certain amount of time, so forth. If it is growth, this r, this is kind of like the rate of growth. This r would be positive for growth or decay, I guess I should put it. Negative for decay. T is time. And this little dude, this is one symbol, n sub 0, called n naught. And it's the original amount that you have. It's just the original number of things. So, it's the same function, really. And I can't remember now if this book makes a big deal out of... no, good. Good book. Let me show you an example of what has to happen here. Very often what we'll do is we'll mimic what we do in science. We'll observe what happens. We'll figure out something with this that's an unknown, and then we'll use it to predict something else. So for a certain type of bacteria, let me see if they have some bacteria. No, that's people, Jeff. Here's bacteria. Let's say we start off with, culture starts with 10,000 bacteria. And it doubles every 40 minutes. How long until the Earth is overrun? I mean, yeah, not too long. Let's see, what do they ask for? Blah, blah, blah. Okay. Oh. I should get a little ahead of myself, am I? I should do that. Let's say find a function in this form that models the situation. So what is it that I don't know in that equation? No, I know the time. I know that I know how much I start with. So what's that? What's this going to go in as for a variable? Which variable is that? N naught. So that's my original amount. That's 10,000.
Did you say n naught?
N naught. Yeah, sorry. The time is going to be 40 minutes.
Would you say it have anything to do with the doubles?
Good. Now what about that doubles?
The rate.
What's the rate?
So after 40 minutes, so n of 40 equals 20,000. I love it because it doubles after 40 minutes. So if I let 40 minutes go by, after this original amount of 10,000, I'll have 20,000 because it doubles every 40. You guys with me? We don't know yet, Jeff.
Is that, so n of 40, that relates to the first part of the function, n of t?
Exactly. N at time t is this business. I know what the number's supposed to be because they told me it doubles. It doubles every 40 minutes. So that's how I can write what they told me in NAFISH. Right? So then I can kind of finish this out to figure out what R is. That's the last. I don't know what R is. And this actually, I mean, this is what it's like in real life. In real life, in physics, you have a spring, you hang something from it so you can tell what the constant is that determines how much it's going to change how long it is based on how much weight you put on there. And here you do something, you get some new bacteria, you let it sit there, you let it grow, and then you can figure out what R is for that kind of bacteria, what the rate of growth is. Or maybe in different situations. Okay, can you grow in this stuff? Yeah. Sure. Can you grow in that stuff? Yeah, we're in trouble. Right? It's growing everywhere. So now I just fill in what I know. So n of 40 equals 10,000 e to the 40 r. Is that cool? Because the only thing I don't know is r. R. How's this guy doing? Is he all right? Yep. What's n of 40? 20,000. What's the next step here? Beautiful. Divide by 10,000, so I get my thing with my variable in it by itself. Of course, that'll end up with 2 there. And the funky thing is, they did not need to tell me this 10,000. They actually didn't need to tell me that. They could have just told me doubles every 40 minutes, because then whatever, it's always going to end up with this divided by this will be 2 for this length of time. Whatever they started with, when I divided into whatever the hell this is, it's got to be 2 if it doubles in that length of time. I don't know if you guys are with me. Because it might, I can't remember, they might do that to you somewhere in the homework. They might, it feels like they didn't give you enough information, but they did. You just got to put a 2 there if they say doubles.
So
How do I...
N of t would be 2?
No.
No. N of t
In general, if
divided
it
by-
doubles every 40 minutes, in general, then n of 40 will be twice n naught.
Yeah.
So then I can just put a 2 n naught equals n naught. The n naughts cancel and end up with 2. If they say it triples in 40 minutes, the same idea, I end up with 3. Okay? And then how do I solve that for r? Beautiful. Take a natural log. So I've got r equals ln of 2 over 40. And then whatever the hell that is. Yes, ma'am.
So the only way that starting at 10,000 would matter is if they asked how much time after how much time would it be? That's the only time.
Exactly.
Because we're just considering rate right now.
Exactly.
Okay.
Cool. So I'll show you a part B to this where it would matter. Here's part A. What do you guys get for that, or the way?
0.017.
0.17, roughly.
Minutes.
It's like 1.7% growth rate. Is another way to kind of interpret that. Okay. So now part B could be how long before we have 120,000 bacteria. So now we have and we know this is going to be what now? Oops, I left out my 10,000. This is going to be, yeah, you make it 120,000. You force the equation to tell you, okay, if this was 120,000, how much time would that have to be? So here's where I definitely have to know that 10,000. That's where I started. You know where I started. And I just attacked this the same way we just did. We're solving for t instead of r, but it's the same idea. So now when you divide by 10,000, you get 12. Okay. So it makes sense that this section comes immediately after talking about how to solve these equations, because we end up with these equations when we have this kind of problem. So now you take the ln and you solve for t. Just divide that out. If you do that, you get 146?
Yeah.
Yeah. If you think about it, you can kind of estimate it, because if it doubles every 40 minutes, starting at 10,000, 40 minutes later is 20, 40 minutes later it's at 40,000, 40 minutes later it's at 80, 40 minutes later it's at 160. That's too much, so this is 40, 80, 120, 160 minutes, so 146 minutes makes sense. That'll be right in between 80 and 160, which is right where I want to be for some reason. 120,000 bacteria. The world's strangest scavenger hunt. So why don't we take a break, get that sense we need one. Come back at like 15 after, because I'm not going to keep you too much. I'm not going to keep you the whole way, but we will do some more.